Hello everyone. We studied before functions and we learned that a function has three forms. What are they? So, function has three forms. It could be in equation form or graph form or table form. These are the three forms of a function that we talked before. Now we are going to study the behavior of a function at a specific point, at a given point. This kind of behavior is called limits. Today we are going to understand the meaning of a limit. So any function that could be in this form, y equals f of x. So if we're talking about the function at a specific point, for example 2, this means that y is going to be equal to f of 2, which means the function at point 2 on the x-axis. Alright, let's move on. Let's have a look at this question, example here. We are given a function, as you can see here. What is the value of the function at 0, f of 0? Okay, by going to, when we move at x equals 0 here, which is the origin, right? And look at the graph. The graph has empty circle here at the middle, but this closed circle here shows the value of the function at x equals 0. So f of 0 actually is equal to 3. This is the value of the function where x is equal to 0. Alright, this is the value of the function, which means that where the y value that corresponds the given x value, which is 0 in this case. Alright, great. What about limits? What if we need to find the limit of the function at x equals 0 at the same point? We just need to get approach. We need to approach the value of the function from both sides. For example, like this and like this. We see that the function is getting closer to another value, which is 2. So again, by using the approaching principle, we can see that the function gets closer to another point, which is 2. So we say that the limit of the function f of x when x gets closer to 0 is equal to 2. Again, using the approaching principle, approaching the value of the function when x equals 0 from both sides, this gives us 2. So we say that the limit of the function is equal to 2. I want to explain something here. The difference between the value of the function and the limit of the function. The value of the function when x equal to 0 is equal to 3 here, because this is the corresponding y coordinate of 0 on the x-axis, while the limit of f of x when x is equal to 0, when x approaches 0, is equal to 2, because the function approaches 2 from both sides, as we did here on this graph. So again, limit, what is the meaning of the limit? The limit is different than the value of the function. It means that the value that the function gets closer to from both sides at the given point. Again, the difference between the limit of a function and the value of the function is very important. The value of the function is the corresponding y coordinate, but the limit of the function is the corresponding or the y coordinate also, but which one? that the function gets closer to from both sides. The function is approaching from both sides. Let's take another example here. Let's have a look at this example. We have another function, y equals f of x. As you can see here, it's given as just one continuous line. All right, no gaps on this line. Now, what is the value of the function when x equals 0? Okay, function when x equals 0, we see that f of 0, the corresponding y coordinate of 0 is equal to 2, which is here. Okay, let me use a pointer. Here, this point here is the value of that corresponds x. Let's now talk about the limit. Today's lesson is about the limit. The limit of f of x when x approaches 0. This is x approaches 0. We're going to approach this from both sides on the graph, like this and like this, from both sides. Okay, like here, this way and this way. Okay, we should get the same point. The function, when we approach the x equals 0 from the right, the function gets closer to 2. Let's approach x equals 0 from the left, like this and that. Okay, also we get also 2. So in this case, we say that the limit of x is equal to 2. Why? Because the graph is approaching this y value from both sides. Okay, whether or not the value of the function is equal to 2 or not. This is another thing. This is irrelevant to the limit of the function. So the limit is a description for the behavior of the function at a specific point. All right, hope you get it. Let's move on. Okay, also here the function f of 0 is equal to 2. Yes, of course, because this is 0 on the x-axis, the corresponding y value is 2 in this case. So the value of the function could be equal to the limit or not, but they are not the same, whether they are equal or not. Okay, let's move on. Another question. We have here another graph of a function. Let's see what do we have. We need to find the limit of f of x when x gets closer to what? To 1. This is 1 on the x-axis right here. So we're going to approach 1 on the graph using the graph, along the graph of the given function, of course, from both sides. I'm going to get closer to this point 1 from both sides. Let's see here. Okay, approaching it from the left gives us what? Y value, which is 1. Approaching 1 from the right, as you can see, gives us another point. So now here, when we approach f of x equals 1 at point 1 right here, from both sides we get two different values. The approaching principle here gives us two different values, so this means that the function doesn't have a limit. The limit doesn't exist. The limit exists only and only if it reaches the same y value using the approaching principle. If we approach it from the right and from the left and we get the same value, we say that the function has a limit at this given point. Okay, so they must be equal to say this function has a limit. If they are not equal, if the approaching principle gives us two different values, we say that this limit doesn't have a limit. This function doesn't have a limit. Okay, by the way, let's find the value of f of 1. F of 1 is the y value that corresponds 1 on the x-axis. So I'm going to start here. This is 1. Here, this is an empty circle. So 1 doesn't belong to this part, to this piece of the function, because this is a piecewise function. This is a piecewise function, 2 pieces. It's formed of 2 pieces. Now here, 1 doesn't belong to this piece, but it belongs to this closed circle here. So f of 1 is equal to what? F of 1 is equal to 2, as you can see here. So here in this example, the value of f at 1 is equal to 2, but it doesn't have a limit at this value. So let's sum up all what we talked till now. We talked that the limit of the function at x equals a is equal to L. How do we find it from the graph? By using the approaching principle from both sides, and it should give us the same value. Okay, x is approaching a. It doesn't mean equal to a. It's not equal to a. It's approaching a, as we saw on the graph. Now, the limit of the function f of x is equal to L, and also we took the value of f of the function at a. These are two different pieces of information, two different concepts, two different ideas. This way, the limit describes the behavior around 1, at 1. Here, it gives us the exact value of the function when it's equal to what? To a, to the given value. So these again and again. The limit means the behavior of the function around 1, closer to a. But here, it means the exact value of the function at x equals a. And the value in this case is going to be the corresponding y variable. Remember that a function, to have a limit, it has a limit at x equals a if the approaching principle gives us the same y value from both sides. Let's continue. Now we are going, they are not the same, of course. Now we are going to learn, so this is what we talk, the limit of the function f of x is equal to L, and it is different than the value of the function. Now, we say that the limit of the function is equal to L. The function f of x has a limit if the approaching principle from both sides, right and left. Right and left can be represented like this. A minus x is approaching a minus means left. So this way we say that, well, it's just describing the approaching principle from the left. X is approaching a from the left, a minus, right? And also from the right, if x, the approaching here a positive, means approaching a from the right, right? If we both give us the same value L, in this case we say that this function has a limit at L. Its limit is L at x equals a. This is just a mathematical way of what we did before. Nothing new till now. Again, nothing new till now. We are just describing what we did before. A negative means approaching from the left. A positive means approaching from the right. If they are both equal, so the function has a limit at this point. This is what we are going to do right now. We are going just to estimate it from the graph, or calculating it from the graph. Okay, let's continue. Okay, we have this graph again. All right. So limit of f of x when x equals 0. So let's do it mathematically. How can we answer this? First, we need to find the limit of x when x approaches 0 from the right. This can be written like this. The limit when x approaches 0 from the right, the limit of f of x when x approaches 0 from the right is equal to 1, and this can be shown here on the graph. The behavior of the graph approaching x equals 0 along the graph of the given function gives us 1. So we say the limit of f of x when x approaches 0 from the right is equal to 1. Let's do the same thing from the left. Okay, getting closer, approaching x from the left. Approaching x equals 0 from the left gives us also 1. This can be written mathematically like this. The limit of f of x when x approaches 0 from the left, 0 negative, means 0 from the left, is also equal to 1. It is also equal to 1. Now, since the function has a limit from the right and the same limit from the left, we say that the given function here, the limit f of x when x approaches 0 is also equal to 1. It is also equal to what? To 1. Okay, so again we are doing the same thing, but this way we just use a mathematical way to represent or to express this. Let's move on. What if we want to find the limit of the same function again, but when x approaches 1, this time when x approaches 1 here? So this means that I'm going to approach 1 from here, from the right and from the left. If they give us the same value, so there is a function, there is a limit at this value. If not, if we got different values, we say this function doesn't have a limit. Let's check first the limit. This is x equals 1, of course, this is the value. We're going to approach 1 from the right and from the left. Approaching 1 from the left gives us x approaches f of x. When x gets closer to 1 from the left, we say that 1 gives us 3. So the y value or the corresponding y value, okay, as we get closer to 1 from the left, we see that the function gets closer to 3, its y value. All right, let's get closer to the same value 1, but from right. Okay, getting closer to from the right, as you can see here, it is also gives us 3. So approaching limit of x when x approaches positive 1 from it gives us 3. So as you can see now, the limit of f of x when we approach 1 from the left or the right from both sides using the approaching principle as we did before gives us the same value. So the limit of the function here is also 3. It must be 3 because the limit from the right is also equal to the limit of from the left. Let's continue. We have another function here, a little bit weird, but it's okay. We are going to also use the same ideas. We need to find the limit of the function f of x when x approaches 1. This is 1 on the x-axis. Okay, this is 1. Let's approach 1 along the graph from both sides and see what we have. Approaching 1 from the right gives us, what is the y value? It is just 0. Okay, when we approach 1 from the left, okay, just a little bit before 1, we see that the graph is getting closer to what? To 0. Let's do the same thing. Yes, 0, of course. Let's approach 1 from the left. Approaching here 1 from the left, we see that also 0. Again, remember that this means approaching limit of x when x approaches 1 negative. 1 negative means 1 from the left, 1 positive means 1 from the right. Okay, now as you can see, the two limits are equal, so the limit of f of x when x gets closer to 1 must be also equal to 0. Let's take another question. What we have? Yeah, we need to find the limit of f of x when x gets closer to 4. Again, the same function here. We need, but this time we need to get closer to 4. 4, I think 4 is closer to 2, right? This is f of 2, but let's describe the behavior of the function just a little bit before around this point, right? Not exactly 4, because this is a limit, not a value of a function. Okay, this is 4 on the graph. Let's approach it. We're going to approach it 4. This is the value of 4, of course. Approaching 4 from the left gives us 2. So we say the limit of 4 from the left, 4 minus means 4 from the left, which is 2. Approaching it also again from the right gives us also 2. So as you can see here, we have the same value in the questions, the same limit from both sides. So we say that the limit is 2. Let's continue another function here. Okay, same ideas, but again, just we need to write this mathematically. We need to find -1, the limit of f of x when x approaches -1. This is -1. If we, okay, let's see how can we write a positive and a negative. Again, to do this, we need to find, this is -1 on the graph. We need to approach this from both sides. Let's see, approaching -1 from the right gives us, remember the y value is this, y value is here, okay, gives us, okay, this 1. So again, as we approach this value, we still the y value is also 1. Let's again find the corresponding, or the other one, the other function limit. As we get closer to -1 from the left, right, the function is also gets closer to 1. So the limit of f of x when x gets closer to -1 is also equal to 1. Okay, let's look at another thing. Any question? We need to find limit of f of x when x gets closer to 1. This time 1, positive 1. This is positive 1. Now we need to get closer to this. The limit of the function when x gets closer to 1 from the left. From the left means 1 negative. Okay, the negative is written on the right. And okay, and a little bit to the top. A little bit to the top, right here. The graph gets closer to also 1. So we say the limit of f of x when x gets closer to 1 from negative. 1 negative, 1 from the left. Notice that 1 negative here, the negative sign is written a little bit up as an exponent, right? But it's not an exponent or power. 1 negative means 1 from the left. Let's again approach 1 from the right. By approaching 1 from the right, as you can see, the function gets closer to what? To 2. So we say the limit of f of x when x gets closer to 1 positive. 1 positive again means 1 from the right, not positive 1. Positive 1 is written before 1, not after 1. Well, positive here is a power, small power here, a small positive, small sign. As you can see, the limit of f of x, which is here, is equal to 2. So we say that the limit of f of x doesn't exist because the limit or the approaching principle doesn't give us the value, as we can see here. Approaching 1 from the left gives us 1, approaching 1 from the right gives us 2. These are two different values. Another question, I think this is the last one. Okay, let's look at this. Limit of f of x when x gets closer to -1. What is -1? This is -1 on the x-axis. We're going to approach this value from both sides along the graph of the function. Here, -1. Let's approach this value from the right. As you can see, the graph of the function, the limit, it gets closer to -1, this value here. As you get closer to here, the corresponding y value becomes -1. And again here, remember, this is just a description of the behavior of the function around this point. Okay, the limit of the function when we get closer to 1 negative is also -1. So the function here has a limit at this point, which is -1. Let's find the graph of the function. Okay, at 0, here is 0. 0 is exactly here at the middle, the origin. Let's see what we have. This is 0. Okay, by getting closer to 0 along the graph, of course, let's get closer to 0. The graph, as you can see, it gets closer to positive infinity, right? There is no y value here. The graph doesn't have a corresponding. It keeps going on and on forever. So we say the limit of f of x when x gets closer to 0 from the right means 0 positive. 0 positive. Positive is written as an exponent, remember this. It's equal to positive infinity. There is no corresponding y value. It goes on and on forever. Let's look at, okay, we're going to reach it from the left. As we reach it from the left here, Okay, this is the graph getting closer to 0, 0, still away. And as you can see, okay, the more you approach, all right, the further you get. It's heading to negative infinity. There is no end for this. It doesn't have, so negative infinity. So we say the limit of fx when x gets closer to 0 from the left, or 0 negative, it's negative infinity. As you can see, the two pieces of the limit calculations or the approaching principle are different, and therefore we are approaching two different values, which means the limit doesn't exist. There is no limit for this function at 0, but there is a limit when x gets closer to 1. So to sum up all what we talk right now, we say that the limit of the function f of x, if it's equal to a value, right? But what does it mean? And it is the behavior of the function around this value a before it gets closer to a. So this is just a description for something else rather than the value of the function at this specific point, which we show this using f of a. F of a means the exact y value that corresponds a. Okay, now we also talk something else, not the same. To describe the limit, you must use the approaching principle, which tells us to approach for the value, the given value, from both sides. This can be written mathematically like this: the limit of f of x when x approaches a from the right, a positive, or the limit of f of x when x approaches a negative. Negative means a from the left. If they give us the same value L, therefore we say this function has a limit L. Thank you very much. Hope you understand this. Hope it's clear. Thank you. And next time, inshallah, we will take how can we find the limit from, how we can calculate the limit from the table form and the graph form. Remember that a function has three forms: graph form, which we talk right now, table form, equation form. We learned it in this lesson. We learned how to find the limit, how to calculate the limit from the graph form. Next, we'll take how to find it from the table form and equation form. Thank you very much. Goodbye.